Hi everyone, kia ora koutou. I'd like to wish you all a very warm welcome to the Utilities and Asset Management session, part of the New Zealand Esri User Conference Series. Thank you for joining us today. Over the next 90 minutes, we will be hearing about how GIS plays a role in asset management and utilities, and learn about some technology updates, as well as hear from the users of ArcGIS from the industry. My name is Megan Cheong, and I'm a GIS Technical Solutions Consultant at Eagle. I'll be your host and one of the presenters today, but I'm also joined by a couple of my colleagues as well as some guest presenters who will be showcasing some industry stories. So what we'll be covering in the next 90 minutes. First, I'd like to explore how GIS and the power of location can optimize asset management best practices. I'll then pass it over to Scott Campbell, who will take us through GIS and asset management integrations. Then I'd like to welcome back David Habercorn from PowerCo, who's going to give us an update on their renewal planning tool. Continuing on that asset management front, I'd like to then invite Gert van Maren from Esri, who's going to showcase some of the upcoming asset management solutions. I'll then be giving a refresher on the ArcGIS utility network and then show some demonstrations using the utility network editor. Then it's time for our second industry story. Matthew Dornan from Transpower will take us on a tour of their interactive and visual reporting tool. And rounding out the session, we'll explore some partner solutions that help optimize the value of your existing GIS. To finish off, we'll have a Q&A with all our presenters today. So this session will be recorded and uploaded to our Eagle YouTube channel. We also have an opportunity for our presenters to answer any questions you may have. So if you do have any, please pop them through in the questions panel on the right-hand side. And we'll be collating all the questions, so if we don't get a chance to answer them today, they will be answered and sent out later. So with that, let's kick off the session. I'd like to explore how ArcGIS plays a role when it comes to asset management. So asset management has been around for a long time now, and its definition and our understanding of best practices has also evolved. I'm going to run through some of the ISO 55000 definition of what asset management entails, and then I'm going to relate them back to how location is enabling organizations to move through different maintenance strategies and plans to better enable their utility. Let's start by defining asset management. Asset management has always been a balancing act. The objective of asset management is to maximize the performance of the assets while minimizing risk and doing this within existing resource and cost constraints. Asset management is a coordinated activity to realize value from assets over its life cycle. Now, this is a significant part of defining asset management plans. Firstly, we need to identify the need for the work, planning out the work, acquiring new assets and going through the logistics and commissioning of them, and then the actual life cycle of operating and maintaining that asset. And finally, towards the end of its life, disposing or replacing the asset. While this life cycle is accurate, it is important to understand that there are many different strategies to using this in best practice. Utilities for many years have been trying to move from the more traditional operational asset maintenance plan to a more tactical and eventually strategic one. What we want to do is gain an understanding of where your utility is regarding its current maintenance plan in order to move up to a more proactive and prescriptive strategic tier. Let's now take a quick refresher on asset management plans. Firstly, we look at operate to fail. This is if you have typically a very limited maintenance planning and assets are predominantly run to fail. Most of the work in your work management systems are either corrective or forced work orders. Next, there's the preventative or routine maintenance plan. And this is time-based or planned work whereby the plan is defined by the time or operations. This is easiest to manage based on scheduled resourcing and cost. Now, this is typically defined by the manufacturer or a minimum regulatory requirement. Most people are very familiar with this, and the advantage for a utility is that they get a very good summary to say, here's the amount of work we need to do, and we need to schedule it every 4 years. So it's easy to resource and budget. The next tier up is condition-based. This is where we introduce new concepts like having a health index on assets. This is about understanding what is the current condition of my asset, how is it related to the number of failures, and then we start to bring in insights and analytics to grade our assets. Then we have the reliability-centered maintenance, or RCM. This is about preserving the function of an asset. What functions does it currently perform? How can it fail? And what is the cause of those subsequent tasks if that asset fails? RCM also brings in additional key data for risk and criticality, and this helps to determine the impact and consequence of the asset failure. Finally, we have optimized maintenance plans. Optimized maintenance planning is the bringing together of preventative maintenance, condition-based, and RCM, and it also brings in additional data for financial and operational forecasting. So how can GIS be used to support this? When we look at it, it's difficult for utilities to transition and move from this operate to fail maintenance plan all the way to an optimized plan. It's like thinking of moving from a passive state to a more preventative or proactive and eventually prescriptive state. And there are often constraints within utilities that are holding them back or preventing them from moving from one tier to the next. An example of this is data. People don't necessarily have a good handle on all aspects of their data, like historic data, the currency of their data, and inspections could still be paper-based, which opens up opportunities for data mistakes. So it's a difficult. Another thing is the old adage of we've always done it this way. So it can be a difficult thing to change. So how can we help utilities transition through this? The way we like to talk about ArcGIS is that we have what we call a complete GIS, and there are three main parts of this. There's a system of record, a system of engagement, and a system of insight. The system of record is a single source of truth. The system of engagement is where we light up an organization with sharing and collaboration, both internally and externally. Then there's a system of insight, which is where we can turn all this information into decision-making through visualization and analytics. So all of this is an enabler for all of the industry missions that you see across the top here. And today we're focused on the asset management part. Starting with lifecycle management, it's important to understand the data that is required to set up a preventative routine plan. Typically, what we're looking for is a history of the asset. What has happened to it and how old is it? We can then bring in location to start to visualize and optimize the value that utilities can get, even if they're only at the preventative routine level. There's a lot of value they can get just by bringing in location. So here we have an example of lifecycle management. We're showing the location of poles from our system of record. We can then bring in historical data from our EAM. And here we can see that the EAM has the install date and the expected years remaining. Then putting that in a dashboard, we can answer traditional questions like how many assets are there? How old are poles? What manufacturers are they? When was the last inspection date? And this also allows us to highlight data quality issues, things that are missing key attributes like the make or the year of manufacturer. Now we want to start bringing in the health index of our assets to start understanding the condition of our assets. For example, if we've gone out and had work orders created and we're capturing some of the failure analysis, or we're understanding that there's been a number of faults on a particular asset, you bring that data in, and now we're bringing in that health component into our workflow, and we're moving into a more condition-based maintenance plan. So with a little bit more data, we can incorporate things like the condition, the damages, and the causes. We can start to symbolize by the health index of our assets and identify where there are clusters of poles that may be doomed to fail, and answer questions like why are these areas performing poorly. We can compare health with maintenance cycles or assets that have exceeded their lifespan. If we start to bring in the reliability-centered maintenance, you can see here that location actually becomes a critical element and has a factor in the weighting. We also bring in these other data sets, such as the criticality of the asset. Where is it on the network? Is it influencing critical infrastructure? Is it feeding a hospital? This sort of analysis. So we can bring in the risk and what's the likelihood and what's the consequence of this asset if it does fail. Leading on from that previous map, the age of pole and maintenance status is not the only indicator. We can connect to other data sources and interrogate the data more to find other factors that might be at play. For example, are the poles around the lake more susceptible to rot? Well, we can bring in wetlands and flood zones. Historical data might also show us a high incidence of wind-related damage, so we can bring in a wind intensity map. What about fire or corrosive soils, live traffic? All of this data can be brought together. With these observations, we get a better understanding of the factors involved with the condition failure of our poles. The final stage is looking at how do we move from a reliability-centered maintenance to a state of optimization. So to do this, we bring in some of our advanced analytics and insights and look holistically across all of our maintenance strategies. This is about moving beyond just understanding our maintenance strategy, but also bringing in capital work strategies and future forecasting and how all of that might work together. So we can take all of the insights and bring it into something like a dashboard. So here we're looking at a SAIDI system, which tells us the system average interruption frequency index, so how frequently warnings appear on those assets, and get a look at other metrics like the age and inspection industry, low health ratings, and vulnerability ratings. We can even go further and filter on vulnerability, which gives us an average health index for the vulnerable assets. So we've started with this concept of lifecycle management, and we talked about the identifying the need, the planning, and moving through to decommissioning the asset. But it's really much more than that. It's a holistic approach. So lifecycle asset management requires that holistic and integrated approach, and the best way to do that is through the power of location, bringing all these different disparate data sets together from different asset management systems through your OT data, IT data, and giving you that insight to better understand best practice asset management for your utility. So to finish, I've talked about moving from the operational to the strategic, all the way to the optimal maintenance plan. And location is that key to bring it all together and help us move through different phases. Location is the way we can bring the story together, because location, it holds so much more information than the asset itself. When you bring in context from other layers, it's a really compelling story for your utility to optimize their best asset management practices. With that overview of ArcGIS, of asset management and GIS, I'd like to now pass it over to Scott Campbell, who will take us through some of the integration options and their benefits. So over to you, Scott.
Thanks, Sir Megan. Hey, good morning, everyone. So I just wanted to touch briefly on some of the underlying considerations that you would have in bringing together data sources that Megan spoke about. Megan, I wonder if you could do the slide advances for me. I'm not sure if you could run the PowerPoints for me, that'd be great. Thank you. Cool. So as Megan mentioned earlier, ArcGIS represents those three different conceptual systems: system of record, insight, and engagement. So system of record being where data is stored in a transactional way. It's secure, it's authoritative, and can be accessed in a number of different ways. The system of insight, where the analysis takes place, you're really getting some value from the data. And then engagement from a GIS perspective, that's often about a map telling a story when you combine data sets with other ones. From an asset management perspective, as Megan was talking about, then the information we need might not always reside within the GIS. A lot of the examples that Megan spoke about, the condition information, the temporal data sets, operational data, live SCADA stuff, that might be coming from other systems. And so To get the complete view of an asset and its behavior and its history, we want to be able to bring those data sets together to get that complete view. And so we might have information typically coming from another system of record, a non-GIS system of record, but also maybe from an engagement tool, maybe with some great charting and mapping, charting and graphing, as well as some specific analytics. So what I wanted to cover here is some of the considerations about how you might integrate those different systems. Next slide there, Megan, thank you. So from the point of view of bringing data together, and data integration is a huge topic in itself. We don't have time to cover that in detail today, but I guess as I said, we wanted to cover some of the considerations there. You've got options to bring data sets together. And the trusted and reliable, but maybe not as dynamic as other options, favorite is the export and ETL. That's where I'm bringing information, I'm exporting information from another system, and I'm transforming it and then loading it into the GIS, or it could be the other way around. I'm taking GIS information and loading it into another system. So ETL, or export, transform and load, is a way of moving the data itself between different systems. And often that will form part of your solution to bring these different systems together. But it's not a real-time data view, and although it could be scheduled. Moving up the chain in terms of having a more real-time view might be where you've got access to the database that sits behind the other system. And this won't always be the case, but in some cases you might have access to the SQL Server database or the database that's powering the other system. And you might also be using ArcGIS Enterprise, and there could be an opportunity there to have that integration happening at a database level, which allows you to avoid duplicating data across systems perhaps, and have a truly real-time view. But it really is highly dependent upon the architecture running in the systems that you're using. Another approach is to take advantage of application programmer interfaces, so APIs. So ArcGIS has got a number of APIs available to you developers to take information out, to push information in, or to link the user interfaces so that it appears as a seamless approach. And so we know a number of organizations who are using an API level integration to keep the two systems in sync, as well as to make the user experience, the website that someone's looking at, as seamless as possible. Another way that might use an API itself, another way we're seeing used widely, is to use the user interface embedding. And we're seeing a number of organizations, asset management solution organizations, who've chosen to embed ArcGIS inside their solution. And so you'd have an application which is familiar to their users, and this could be SAP, it could be Maximo. And so where they've actually taken the mapping component and embedded it inside there in the back end, they've got APIs to make sure the data sets are synced to the back end. So from a user experience point of view, it's fantastic, but they've also got some mechanisms in the back end to make sure that the data is kept in sync between the asset view and the GIS view. And then the simplest of all is linking. So if you've got web-based applications, what we often see is people using a URL to link between two applications. So I can click on an asset inside of my asset system, and then the map that represents that asset would pop up with some contextual information, and vice versa. So a very simple way to do linking with URLs, but again, it's dependent upon the workflows that you want to support, and also the applications that you have in your stack. For all of these, there's two kind of approaches. There's the custom approach, so using those APIs, creating stuff in the database, using URL linking that you can do yourself, as well as I mentioned, a number of asset management providers. I've got a few here who've chosen to geo-enable their solution with ArcGIS, and they've done it for you. So IBM, Maximo, SAP, CityWorks, and also Adapt Solutions, a New Zealand company, who've chosen to take the GIS and embed it inside there and do the kind of a lot of the hard work for you. Next slide there, Megan. Thank you. So one of the hardest things about this integration between these two systems, the asset and the GIS, is really identifying what data set needs to be shared, what data sets need to be shared. And often you'll find that there is an overlap of data between these two different systems. And that might be by design, or it might be just for historical reasons. At the very least, you want to have a consistent ID that you can use between systems, so you can identify that the GIS asset is linked to the asset in the other system, and that those are kept up to date. But you may also want to consider having some additional data in there. Sometimes you store data which is mastered in the asset system, such as condition information or historical information or value information. You might choose to also replicate that inside the GIS just for the reasons of performance. So you can quickly render a map and show, hey, show me all my assets by their value, or show me all my assets by the condition, even though the master of that asset condition variable might be coming from a different system. Editing is another thing to think about. Editing is obviously the time when you want to be as most careful around not breaking referential integrity, that you've not got the system with that's the asset being created in one and not the other. And so ideally it's done as an atomic transaction. Sometimes that can be done in a field application, which has been created specifically to create a new asset or update an asset and send those updates into two places at the same time. And that could be a standard field application sometimes, but more commonly, if you want to have as a true atomic transaction, you would have that as a custom application. So finally, just as a consideration, we're not going into in depth here in terms of the integration options. It's a whole topic in its own right. But the reality is that all of you listening will have a GIS, and you'll have one or more asset systems. And so how you integrate those is a really big deal in terms of getting it right, so that the data is not inconsistent and that the user interface is also as seamless as possible. I guess from our experience, understanding the workflows you're trying to digitize in the first instance is really key, and then deciding whether you want to go down a custom approach, creating stuff with APIs and using developers, or you want to go down a COTS approach. And I guess there's a number of asset management vendors who've done some of that work for you. And if you do the custom approach, then developers.arcgis.com would be a great place to start to understand some of those APIs and scripting options to do that integration.
Cool. Thank you for that, Scott. Thank you for outlining the different integration options and talking about some of the considerations that utilities need when they're integrating with the asset management. Thank you for that. So speaking of asset management, I'd like to now pass it over to David from PowerCo, where we will learn how they've integrated ArcGIS with their asset management systems to develop their overhead renewal planning tool. So David joined us in last year's utility session, but we're very happy to welcome him back to give us all an update on how their tool has developed, how they've managed to integrate it with their ERM, and what's in the pipeline for PowerCo moving forward. So I'll pass it over to David.
Kia ora everyone, my name is David Haverkorn and I work as a GIS specialist at PowerCo in Plymouth, Taranaki. Thanks to Eagle for giving me another opportunity to provide an update on the PowerCo renewal planning tool. For those of you who haven't heard of the tool yet, I'll provide a quick overview of what we do, why we need the tool, and what it actually is or consists of. And then in the second part, I'll talk about what we have done over the last year and what's in the pipeline. At PowerCo, we have a broad asset base which is distributed over large geographic areas. As you can see, we have around 260,000 poles which have 425,000 cross arms on them, and they connect around 28,000 kilometers of conductor, serving over 330,000 customer connections. Not only is it a large network in terms of its asset base, but also in a geographic extent. As you can see, our network covers everything from coastal areas to hill country and alpine environments. We have over 1,400 kilometers of coastline, and around 30% of our network is within 5 kilometers of the coast. We are in elevations of up to 1,500 meters, as well in high wind zones and get snow, ice, etc. About 3/4 of our network is in rural areas, of which 22% is classed as remote or extremely remote. But also the asset base itself is very diverse, as PowerCo historically is an amalgamation of different power boards. This means that we have a lot of different poles, different cross arms, different conductor types, and also different standards of how assets have been installed and maintained in the past. Now you can imagine that makes it a bit of a challenge to efficiently manage this asset fleet, especially with the increased workloads that we have experienced over the last years as part of our CPP custom price path. We roughly hit a 400% increase in renewals over the last years. And while our planning engineers tried to use our maps that we had at the time, they did not get too much out of them because they were pretty basic maps and did not offer a lot of smarts or intelligence. So the main tool for them were spreadsheets really, and as you can imagine, this wasn't ideal as they had lots of manual steps, lots of manual data cleansing, lots of inconsistencies, and most important of all, no spatial visualization of what areas to focus on. So we started a project in building a geospatial tool for these guys so that they would be able to discover assets that need replacement easily and consistently. And I'll just run through a few slides of what we have built over the last 3 or so years to give you an idea of what the tool actually looks like. We started relatively simple and started building different maps and layers for engineers to use on a daily basis. Heat maps are a substantial part of the tool as they will paint a big picture view and point our engineers to areas that need attention. We started off with what we call the asset heat maps, and they basically visualize densities of certain defects, condition and type issues. All our heat maps are based on hexagons in different resolutions. Another type of heat maps that we use are the risk heat maps. They're based on our asset and health heat maps in combination with a consequence and criticality layer. Again, this is used by our engineers to assess areas of interest for asset renewal. Our conductor health modeling has introduced a step change in engineering, offering a wealth of new insights and knowledge to our engineers. We have implemented the UK-based CINA methodology, which basically is predictive models for asset health. We have adapted the methodology to suit local New Zealand conditions and the characteristics of a network. This allows us to predict the conductor health across all of our fleet, and this has been very successful so far. It has basically changed how engineers see the network, and we also were able to bust a few myths, which means that, for example, we now avoid replacing assets that actually do not require renewal because they actually are in good condition, where we previously assumed they are not. In order to share outputs of our models, we have also created various maps and dashboards, like the project dashboard, which visualizes all projects currently happening on the network. This also acts as a feedback loop for our planning engineers, as it shows the different statuses of renewal projects and where they are actually happening. Our insights dashboard, on the other hand, is more aimed towards quick analysis of our conductor fleet to answer all sorts of questions. For example, where are our copper fleets and what health are they in? What's the circuit length of conductors in poor health? Or what happens to our conductors in 5 years if we do nothing? This is a really helpful tool to do some quick analysis in a user-friendly way. We have also made heavy use of field apps like Collect and Survey 1 to 3. Our models being predictive, they of course will never tell us 100% of the truth. But by collecting ground truth data, which we use next to physical samples and lab testing, we can tweak the parameters of our models and improve the confidence in the results. We have, for example, run 2 acoustic and visual surveys with Northpower, where we use Survey 1 to 3 to collect data from around 200 locations spread all over our network area. We have basically digitized the forms they usually use for that sort of inspection, and therefore provided them with a familiar interface. We also had a dashboard set up for them showing progress, as well as additional information like weather and traffic. These surveys have been very successful and have delivered field samples straight back into our models for validation. Now, to sum up what the renewal planning tool is, well, it certainly is not a single tool as such, but rather a whole ecosystem of different components like layers and maps, dashboards, and mobile apps. We also integrate with various data sources ranging from our ERP system, our outage management system, to external data sources required for our analysis. And the idea is to keep expanding the functionality of the tool, as well as making it available to more people from all areas within the business. And this leads me to the second part of this presentation. What have we been up to over the last year, and what have we added to the planning tool? I guess one of our biggest wins this year probably was to finally get access to data residing within our ERP system, which we didn't have for quite a while. Since we have migrated to our new ERP system, we had difficulties accessing a majority of the equipment, defect, and inspection data. And now we have built the interface between the two systems, and that means that we can now again refresh the tool on a regular basis with equipment data, defect data, as well as inspection data. Probably the most significant addition in terms of impact over the last year was the pole versus vehicle analysis that we carried out together with Orbico and Christchurch. Vehicles crashing into our power poles are a great safety risk, and all too often we do not even know about it. We have combined our own fault data on car versus poles with NZTA crash data and built a tool that not only shows us poles that already have been hit in the past, but it also calculates a risk score for all poles. This risk score, among others, is based on road risk that was calculated as part of this analysis. We have split up the NZTA road center lines into 100-meter segments and then calculated a risk based on various factors like sinuosity, camber, surface type, slope, and many others. The powerful part is that the road risk has been calculated for each side of the road. This is important because if we plan a new asset or want to shift an existing asset, we do not want to put it into an area that has an equal or even higher risk than where it already is. So this tool has identified around 800 very high risk poles, and this information is now considered when planning renewals, as well as a new strategy on replacing these high risk poles is being worked on. So this really is a win-win situation, as we can improve both public safety as well as potentially make our network more reliable due to less incidents involving poles. Another big change that is coming up is that we are in the process of migrating our health and risk models into Copperleaf, which is our asset investment planning and management solution at PowerCo. This also means that we are working on a solution to bring any data that is processed within Copperleaf back into the spatial domain, so that it can be displayed, analyzed, and used within our ArcGIS environment. On top of that, we're also expanding our asset health modeling to power poles and cross arms for now, and further asset types like transformers will follow. And of course, there's always more in the pipeline. The team constantly comes up with new ideas of what we could build in GIS. And we have started taking pole top photography, for example, and we'd like to integrate that information into our tool. We have also flown the whole network in LiDAR recently, and this of course holds a massive potential of information, especially when it comes to vegetation. So we'd like to integrate a bit more information on vegetation planning in the planning tool as well. And another part that we'd like to work on is aeolian vibration. Vibration can cause significant damage in conductors, and it is very hard to detect during a visual inspection. We therefore would like to model this phenomenon within our tool to learn more about aeolian vibration in conductors going forward. And that's my update on the PowerCo renewal planning tool. Thanks again for the opportunity, and feel free to flick me an email if you have any questions, or just flick some questions in the discussion afterwards. Thank you.
Thanks very much, David, for giving us an update on the PowerCo tool. It was good to see you integrating different data sets within your GIS and resulting in a tool that's useful to calculate risk and criticality. And yeah, it was really cool seeing how you integrated as well the road centerline data to calculate risk for your poles. David, like the other presenters, will be joining the Q&A at the end, so please do keep sending in your questions. So we've heard about some examples of how we can tailor ArcGIS to our asset management workflows, but how about pre-configured out-of-the-box asset management solutions? To tell us more, I'd like to now pass it over to Gert van Maarden from Esri, who's going to share some of the exciting and upcoming 3D asset management solutions. These include tree management, inventory, all the way to feature extraction using LiDAR. So I'll pass it over to you, Gert.
Hi, my name's Gert van Maarden and I work for the ArcGIS Solutions Group. And today I'd like to talk to you about asset management and ArcGIS solutions. So first off, what are ArcGIS solutions? These are industry-specific maps and apps provided by Esri. They're fully pre-configured workflows for various industries, very easy to deploy, fully supported, and available at no cost. We have about 100 of these workflows solutions available, and I highly encourage you to have a look on the solutions website, arcgissolutions.com, to see what's available for you. These solutions are part of the ArcGIS product lineup, so they work very well with Pro, mobile apps, ArcGIS Online, and Enterprise. But when we look at asset management, we see that these asset management workflows have all common business challenges. Typically, there is not an accurate digital inventory, and it's hard to maintain that inventory. The assets might have different maintenance needs, and users need reporting and tracking to demonstrate value. And what we often see as well, there might be manual systems or legacy systems. So that's why we started working on a number of asset management solutions for different assets. And the first to be released is the tree management solution, due in November of this year. It will have a number of components, such as a Pro project to create and manage the asset inventory, apps for office and field staff to collect, view inventory, and complete assignments, a dashboard to monitor performance, and a hub site and tree viewer for public engagement. So let's have a closer look at some of these components. Critical for a successful urban forestry program is an accurately maintained inventory of trees. Many communities have an existing tree inventory, and to help them get going, the solution will have a Pro project with tasks and tools to help load the existing content into the feature layers that will be deployed with the solution. For users that have LiDAR data, as you see here, the Pro project will include tasks to classify the trees in the LiDAR data using a deep learning model, extract the trees, and load those tree points again into the feature layers. And once the organization has loaded their tree inventory, they are ready to begin improving their inventory and manage their inventory in the field. As we know, field operations are important workflows both in terms of cost and care for the assets. And here we have the Tree Assignments Workforce project. This gives access to the full tree inventory. We can view the details of the trees, when it was last inspected, the most recent maintenance, as well as information about the planting space around the tree shown here in blue. You can also receive a service request from the public, for example, asking for planting some trees on this median. We can create an assignment to plant some trees, we fill in the details, and then hit assign. But you also can create an inspection assignment. And same workflow, you create the assignment, set the assignment type, and fill in the details, and click assign. And once you've done that, we can move on to the mobile app and use this app to view the current assignments. We can begin them and keep them up to date. We can also from here open the tree field map. Now this tree field map gives access in the field to the full tree inventory, and again you can view all the details as well as the most recent inspection and maintenance. So we have this assignment to plant trees. I can turn an available space into a planted tree. We edit the available spaces and convert it from available space to a planted tree. The form updates and we fill in the necessary details, such as common name, genus, species, planting date, and height, and width of the tree. And once that's done, we submit, and we've updated our records. And we can also work on the inspection assignment and assess the conditions in the field. Another component of the solution is public engagement. The Urban Forest Hub site helps organizations provide a destination where residents can understand the benefit of trees in their community and become involved. Residents can view metrics about the managed trees, understand the benefits that the trees provide, and even become a so-called tree steward and care for an adopted tree. There is also a tree viewer, which is built using Experience Builder. And this viewer can be used by a number of different types of users, residents in a community. They can look at the trees around their house, search for their location, create a service request, report a hazard, or even request a new tree planted. And they also can look at individual details of a tree. And if the user has adopted a tree, they can use the report care form to report the work done on the tree, attach an image to show what work has been done, and submit. And last but not least, we will also include a 3D scene in the tree viewer to provide an engaging visualization. The tree management solution will also include a notebook which can be scheduled to regularly update the web scene according to the agency's tree inventory. So the 2D and 3D content are being managed in one comprehensive system, from field data to publicly shared 3D scene through a scheduled process. We are planning to implement this for other assets such as street signs, bridges, and underground utilities. With this approach, we can help you operationalize the creation of your digital twin. And as you manage your field work and maintain your systems of record, behind the scenes you are also maintaining your 3D content, which makes 3D visualization possible without significant GIS experience. The final tree solution will also include additional apps such as monitoring dashboards and additional notebooks to automate workflows. Now this solution sets a repeatable pattern for inspections, automation, 3D content, and public engagement. And it will be released in November of this year. It's the first of several solutions we'll be developing for assets in the visible right-of-way, such as street signs, curbs, sidewalks, and traffic lights, that together will help you manage your assets in a series of lightweight SaaS solutions. And while these solutions are developed with a US audience in mind, because they are fully open source, they can be easily adapted to manage assets in New Zealand. In this case, for example, avalanche paths. Harris Mountain Heli-Ski down south here had these legacy systems of managing their avalanche paths and are looking now at ArcGIS to manage the data inside of the ArcGIS and use ArcGIS as their asset management system. And similarly, you could use these patterns to manage your assets on a ski field. This is an example of Treble Cone, South Island, with all the routes and also webcams, which are then linked to live views on the mountain. Now, why this 3D component? Well, what we know is that when you see something in 3D, it's much easier to understand. You see here a quote from Andrew Bayermans, CEO of Utihoe Farms. Same thing here. Seeing the hazard details in 3D really brings the information to life and makes it much more understandable compared to 2D maps. And this is also applicable when we talk, for example, about flood impact and seeing the impact of flooding on various assets, buildings, trees, etc. But one question we get regularly is, how do I create this 3D data? Now, the ArcGIS system had lots of tools to extract features from LiDAR. It has the ability to classify the LiDAR using deep learning models, and then there are tools available to extract features from that classified LiDAR. And what you see here in the image is that we classified the trees and extracted the trees. We classified the power lines, extracted the conductors, and we're also now working on tools to extract the locations of those power poles. And all these tools come together in our 3D base map solution, another solution that is provided for free at no cost through the ArcGIS solutions. This solution is an ArcGIS Pro project with task-based workflows that allow you to create the output layers that you see here on the right. If you have LiDAR as input, it allows you to extract the bridge surfaces from the LiDAR if those bridges are classified. You can extract buildings at various levels of details and then even extract floors from those buildings. It also has steps to extract elevation surfaces from the LiDAR, like a DTM and a DSM. And as mentioned before, power lines can be extracted using the solutions, as well as trees. There are also workflows to create a 3D representation of your underground utilities, and even tools to work with these integrated meshes. Where can you find these solutions? As mentioned, you can go to arcgissolutions.com that will redirect you to our product pages. And when you get there, you get an overview of what they are, what the business value is, and you can launch directly the ArcGIS Solutions app, which allows you to browse through all the available solutions by industry. And then when you click on one of the solutions that you're interested in, you get more information. You can straight away jump to the doc pages and see how they should be deployed and how they should be used. And then you can deploy them to your organization. Now that brings me to the end of this presentation. For more information, please have a look on our product pages. As mentioned, the first of the asset management solutions will be released in November 2021. That's the tree management solution. And for any other information, please email me on gvamaran@esri.com. If you've got any questions about the 3D base map solution or any of the other solutions, please do so. Thanks for watching.
Cool, thank you for that, Gert. I'm really looking forward to that tree management solution that's coming in November, so stay tuned for those upcoming solutions. I'd now like to talk about some other solutions. So Gert mentioned a bunch of utility-focused solutions that Esri have been releasing, and some of the current solutions include data management solutions for asset management, and these span the telco, electric, water, and gas industries. Underpinning those solutions is the ArcGIS Utility Network. So I'd like to now take you through a brief overview and refresher of this next-gen network management framework and look at how utilities can leverage the utility network in their BAU workflows. The ArcGIS Utility Network has been specifically designed for the modern utility, and it's a framework built upon ArcGIS Enterprise. This means it has the ability to model the complete network. We can look at everything right from the gathering or generation tier right down to distribution and delivery of your specific commodity. The utility network enables complete modeling through capabilities such as containment. So that's being able to represent complex structures such as pump stations or electrical cabinets without cluttering the map. We can also use what are called associations to model implicit connectivity between features that are not geometrically coincident, like a transformer and a connection point. The latest updates to the utility network include the addition of non-spatial objects, allowing you to model down to the individual strand of a fiber inside a cable or a port in a rack. So with more precise modeling comes the ability to have sharper analytics to make better decisions from. On the visualization and analytical side, ArcGIS Utility Network is 3D enabled, allowing for a truer representation of your network assets. You can create network diagrams to allow you to obtain a logical view of the network and check network connectivity. And of course, we can perform advanced tracing configurations, allowing you to better understand the operational health of your network and take quicker action in the event of outages or leaks. Importantly, the utility network is services-based, so this gives your users that flexibility. They can edit the network data seamlessly via web services on connected devices. What this means is your network data is no longer confined to desktop access. You can model, edit, and analyze the utility network across the entire Esri system, whether that be your GIS analyst team working in ArcGIS Pro, to a maintenance crew referring to assets in field maps, or even an engineer running a trace in the utility network editor, which is a lightweight web app designed by Esri UK. At the core of the utility network is a comprehensive and configurable information model that allows for that high fidelity modeling. The data model is flexible and is intended to be extended and modified to suit your business needs. And of course, all utilities have their own set of business rules and network rules. The utility network relies heavily on network rules to enforce network connectivity. So if a rule doesn't exist allowing two assets to connect, then you won't be able to snap them together while editing. This enhances that data integrity when performing common tasks like updating new areas of the network. With the upcoming water reforms, we also wanted to state that we want our technology to support those changes and the needs of New Zealand water utilities. So at Eagle, we are actively working towards a New Zealand water model that will comply with the New Zealand Asset Metadata Code of Practice for Three Waters pipe assets. So please do get in touch with us if you'd like to find out more and have your say in it. So we've just had a high-level overview of the utility network. Now I'd like to take us through a few workflows in action to illustrate some of the capabilities I talked to earlier. This is an electrical distribution network from Network Waitaki in Otago. I can access the utility network from ArcGIS Pro, but in this case, I'm using the utility network editor developed by Esri UK. So with that idea of containment, I can visualize the internals of this electrical cabinet without cluttering my map. I can also turn on and view associations, which model that implicit connectivity between assets that are not geometrically coincident, such as between this network protector and the connection point. The utility network editor allows me to view a graphical representation of how exactly my assets are modeled. So I can see that there are 6 features contained within this electrical cabinet. And selecting on this high voltage transformer, I see that it's connected to the electric high voltage conductor and a low voltage connection point. The services-based architecture of the utility network allows me to work using branch versioning. So as a data technician tasked with updating the network, I have the ability to work from my own version and make my own edits. To highlight some of those network rules we were talking about, I'll attempt to change this to a low voltage transformer. Because it's detected a change in my network, a dirty area appears informing me that the change has not yet been validated against my topology. And when I do try to validate it, I receive an error. So this is an example of those network rules working to prevent data entry mistakes. I do not have a rule in place at the moment allowing me to connect a low voltage transformer to a high voltage conductor. And once I'm done working with my version, the ownership of my version can then be transferred to a version administrator who can then complete those QA/QC processes and then post it to the default version. So in an asset management context, being able to model our features to a high degree of detail while doing so accurately is vital to preserving that single source of truth that we use to make our decisions, our business decisions on. Now let's switch gears and look at a water distribution network and explore some of the operational challenges that come with managing a water network. One of those challenges is ensuring that leaks are quickly identified and attended to. Another challenge is ensuring that customers are proactively warned in the event of any outages. So let's look at how the utility network and utility network editor help address those challenges together. I'm assuming the role of an engineer in the field, and I found and identified a mains leak during a field inspection. I've identified that on my map. So to be able to isolate the leak, I need to know which valves need to be switched off. So to do so, I can use the tracing analysis tool to trace the desired network features from that leak's location. So for this example, we choose the isolation trace type, which will highlight on the map for me all the valves that need to be switched off to isolate this area. What the utility network editor adds in terms of functionality is the ability to create trace reports. So I can quickly identify the details of my asset and then share that with my team. Keeping to that same scenario, I need to also inform the affected customers from that leak. So when the engineer identified the leak on the map in the field, the team back at the office will have received the location of that leak on their map. And to assess the impact this leak will have, I can run another trace. In this case, this is a configured customer isolation trace that will highlight for me all the affected customers. I can run the trace, and that will show me on the map the locations of all those customers that would be affected. Similarly to the first example, I can also configure a trace report. And this report can list the details of all the customers that are affected, and it can be configured to show additional information such as their contact details, and it can be, of course, be exported to another system like a CRM or a customer relationship management system. All of this will optimize the ability to contact customers proactively in the event of any leaks or outages. Now shifting our focus a bit to the road ahead for utility network, I particularly want to draw your attention to the upcoming release of field maps. So this future release will have the ability to support trace configurations, which opens up the doors to performing pre-configured traces in the field on your mobile app. This will allow your work and field crews to have that opportunity to run traces and understand the status of their network based on the latest up-to-date information. You may have seen a demo of non-spatial objects in ArcGIS Pro during the New Zealand NZEUC plenary. Now, the upcoming release of the Utility Network Editor will soon support the editing and interaction of non-spatial objects. So that's features like fiber connectors, ducts, strands, and ports. In the example of a telco network, I can examine the connectivity between these wire vaults, which are joined by a duct, which is a non-spatial object. So as the technology evolves, we'll be continuing to see more functionality being added to both the utility network and the utility network editor to support these increasingly complex networks. Now going from the utility network to something a little bit different, I'd like to introduce our second customer story of the day, Matthew Dornan from Transpower. She will be sharing with us how they developed a spatial tool to complement their planning report. So I'll pass it over now to Matthew.
Hi. Picture this. You own a distribution network. You're expecting a lot of new load to show up within your network. Instead of scrolling through a document to figure out how you might supply this extra load, imagine if you had a map that shows you exactly where the upgrades are planned on the transmission asset you're trying to connect to. Also, you could overlay your network map onto the transmission map. And that's exactly what the TPR Envision allows you to do. Hi, I'm Madhi Donan and I manage the geospatial team here at Transpower. The system planning team, on the other hand, in Transpower is responsible for designing a transmission grid that is fit to meet our future needs. Annually, they publish the transmission planning report, which can be between 350 to 400 pages in length. I'll briefly take you through how both the geospatial team and the system planning team work together in making transmission planning visual and interactive. I'll cover what is the Transmission Planning Report and the TPR Envision is, why we decided to make it into a visualization tool, what we needed the tool to do, and a brief demo of how that works. Transpower uses a 15-year demand forecast to determine where and when there are going to be issues on the national grid and investigate how we might resolve it. Every year, the system planning team spends time identifying and studying the issues coming up in each region to produce an mammoth document. It's informative but hefty document, about 350 to 400 pages, called the Transmission Planning Report. Our main readership for the document has been planners at distribution companies who use the data in the report to identify upcoming issues that might affect them within their region, to then initiate a conversation with us. The TPR Envision is a digital tool which displays transmission planning information on a visually interactive map of New Zealand. It gives you an accessible and interactive resource to navigate transmission network upgrade information that's relevant to you. You can find out which issues on the grid were coming up and why, what needs to be done about them, by when, and how much it might cost you, all within a few clicks. So why did we need a visualization tool? Our customers are evolving and so are their needs, especially obtaining information from an almost 400-page document. And GIS gives us a tool to deal with some of the communication challenges the document format has imposed on previously. The information that is held within the TPR is highly interrelated. So the interactive way of sharing information within our stakeholders is progression towards digital transformation. We followed 5 principles in developing this tool and identifying the requirements. The underlying purpose of TPR was to provide details on the grid asset capability over the next 15 years to our stakeholders. A lot of resources are invested into analyzing and modeling this large data. So data is an asset to our organization and is useful when it can be discovered, shared, and used, especially how Transpower plans to develop New Zealand's electricity transmission network over the next 15 years. We wanted to use existing investment in technology to make accessing the information easier and quicker. We are in a world where users' needs are to access the information at their fingertips, and our in-house technology was utilized to deliver this. It was clear from the beginning that the interactive visualization is of prime importance. For systems interacting with geospatial data of any extent, the two capabilities are of interactive visualization and integrated data are intertwined, so we provide an easy-to-use tool to complement the report. We had to compromise some creative ideas from the system planning team for user-friendliness in ArcGIS. And configurable existing templates were used to update the attribution and support features. With minimal customization, we were able to build a user-friendly mapping application without using a developer or a designer. TPR Envision was created using our own brand without any coding. The value of the solution was in using out-of-the-box application because number one, the vendor, Esri, maintains the software and releases the updates online. And number two, able to keep our automation in the back office with a simpler upgrade path. Another functional requirement was a seamless link between the application and the document. So the application was configured to navigate the user from wherever they are geographically on the map to the appropriate section in the report. As I mentioned earlier, the interactive tool was built to complement the report and not to replace it. So I'll give you a brief demo. This is the features of the tool. So on the left, as well, application, there's a layers and a legend tool, and there's a list of selectable layers, which is really useful so that you can only display what you need. You can show transformer or circuit overloads, information about upgrade projects, and how much load generation there is at any site. Use the bookmark to quickly zoom into a region you're interested. Let's check Wellington out for this demo. And by clicking anywhere within the regional boundary, you can see a short regional background. But what's more useful is that this will also link you to the relevant chapter within the document. As you can see, you've been automatically navigated to the chapter. And with a number of layers, you can also turn all the layers on if you like by clicking that button. Zooming closer to the Wellington region, the pink line shows the significant upcoming work at Gracefield to Haywards. And this one shows you, and also the link to the report. And this one shows you the same at a site. You can see there are multiple layers of information, one of 12, because we've turned all the layers on. And this shows you there is an upcoming $23 million project at Central Park. Again, you click on the link and it will take you to the Wellington chapter, and scrolling or going to the relevant section, it'll tell more about the Central Park project itself. Moving over here, you can see that Westwind generates 143 megawatts of power. And again, you click on the document and it will take you to the relevant chapter of the Westwind of the report. And as with many of the applications, you can change your base map to suit your needs, and it has the basic gallery of base maps to choose from. Say you're a generation developer, and one of the useful features of this tool is you can add your own data. We are using Kaimai Wind Farm as an example. Here you can see the placement of each turbine in relation to the transmission line. And it's automatically added the layers for you on the left-hand panel. And by zooming out a little bit, and selecting a few useful layers like demand and generation, you can see the size of the load nearby, like Waiho over here and at Piako. Now let's have a look at what enhancement projects are in this area. They're shown in yellow. You can see there is a constraint on the Hamilton to Piako circuit coming up, which might impact your wind farm project. And you can jump into the document to read a bit more about this constraint before coming to talk to us at Transpower. Now say you would like to electrify your dairy factory again. You can start by adding your data to the map like this. It'll automatically zoom into the data that you've just added. Conveniently, your plant is very close to the Edendale to Bryden line. And let's select the layers That shows us where we may have overloads coming up, which is shown in red. And if you click, you can see Edendale already has an N-1 transformer overload, which increases over time, or that Go has one coming up in 2025. And the circuit between Go and Halfway Bush also has a line overload coming up. You might want to talk to Transpower if it will affect you. Now, turning on a few more layers here. The purple mark shows us significant upcoming work. And there are some risk-based replacements at Edendale and Go in the future. And these few more layers, which is the yellow marks, shows you that upgrading transformers at Edendale costs about, where is it, $9.9 million, and its need date is now. Or there is a Southland 100 kV capacity issue. And once again, you can jump onto the Otago Southland regional chapter of the TPR document to find out more. So what's next? TPR Envisions had the same number of views in a week that the document gets in a year. It's good to know that people have found it useful, but we are always looking for ways to improve our tool. For example, if you are an international investor that is unfamiliar with New Zealand's geography, you can use TPR Envision to understand the lay of the land. If you'd like to invest in a solar farm and have an idea of which parts of New Zealand are the sunniest, but you don't know where you can connect to into the transmission grid, instead of inquiring about 200 locations, we are looking at how we can help you narrow down your search for sites by developing a tool that shows you where there is capacity available already. So along with some functional changes as well. So look out for the 2021 publication of the Transmission Planning Report and the TPR Envision. Thank you.
Thank you very much for presenting that, Matthew. It was great to hear how much more engagement the EPR Envision tool received compared to when it was just a paper report. So that really demonstrates and highlights the value of being able to visualize and interact with spatial data. If you have any questions for Matthew, please keep sending them through the panel, and she'll be on the line as well at the end. So our session so far has exposed us to many different ways ArcGIS can be leveraged. We've looked at how it can be used in asset management, network operations, both in the electric and water context, and just recently communication and engagement, to name a few. So now let's take a look at some partner and complementary solutions that are out there that can integrate and work with ArcGIS. The first one I'd like to talk to is ArcFM Editor. So ArcFM Editor is an add-in to ArcGIS Pro, and it adds advanced functionality on top of your utility network. So that's things like more complex traces and streamlined editing processes. I'd like to speak to a couple of the new enhancements to ArcFM Editor 11. There's a new Conduit Manager 11 for the utility network. This allows you to quickly create and manage dense underground facilities like vaults, manholes, and ducts, and you can do so in 3D. There's also a better validation experience. For those of you who are already working with the utility network, you'll know that when you receive an error, it can be sometimes a bit difficult to identify what the exact error is and what we can do to fix that error. So the new ArcFM Editor has a new, better, human-readable validation experience. With that, I'd just like to jump into a quick demo of the new Conduit Manager. So in this example here, I have a vault in the middle of my map, and there are some ducts running into it, and there's a mixture of round and square ducts. On the left is the layout editor, which is part of that new Conduit Manager. So what I'm going to do is go ahead and create a new duct bank. So snapping is enabled, as you can see, so I can quickly snap that new duct to the vault wall. I can then fill in its attributes, such as the number of rows, columns, the depth, material type, and so forth. And once I'm happy with that, I can go ahead and click Create. And what it's doing in the back end is not only creating the ducks and the duck bank, but also all the associations and containments that are required to run an open duck trace. So now that's created, and when I click on the vault wall, I can see that the ducks that I just created there for me. And of course, I can visualize the duck bank in 3D as well for better clarity and really bringing your data to life. Next, I would like to talk about Clarion. So Clarion is one of our partner solutions. Electric lines companies may spend a lot of money ensuring that vegetation doesn't encroach on their overhead lines. So to streamline that process, Clarion has a solution built with ArcGIS to create detailed work plans, issue work orders, and track inspections. With that, I'd like to quickly pass it over to Chris Kelly, who's kindly shared us a short video of the latest enhancements to Clarion.
Hi, everyone. My name is Chris Kelly, and I'm the CEO and a co-founder here at Clarion. Clarion builds software solutions that extend the Esri platform to support the planning and management of complex multi-year maintenance programs. We're thrilled to have the opportunity to join you at this year's conference. For those of you we haven't met, we're excited to share how we help solve field operations challenges that leverage your Esri investment. For those of you who already know Clarion, we have some exciting technology announcements to share about our new software products that work with the latest enhancements to the Esri platform. Our solutions support tree maintenance and right-of-way vegetation management for electric transmission and distribution operators. We also support inspection and maintenance of electrical assets, roadside vegetation control and highway asset maintenance, emergency response for storms and other natural disasters, wildfire prevention and risk management, as well as supporting sustainability and community engagement initiatives that can be integrated into our asset and right-of-way management programs. Our software products extend the Esri ArcGIS platform to automate complex maintenance workflows. We offer a web-based work management module as well as a cross-platform mobile application that supports the full range of field worker roles. All of the data created and managed in Clarion is stored natively in an Esri database and can be accessed through off-the-shelf Esri applications like Operations Dashboard. Our software solutions have delivered benefits like streamlining back office processes and improving field worker efficiency. Clarion also helps you manage large multi-year work programs to ensure you meet your safety, compliance, and customer service goals. While we've worked in New Zealand for many years and enjoyed close ties with Eagle Technologies, we're pleased to have recently formalized our relationship with Eagle for the deployment and support of the Clarion solutions. Our cross-platform field application works on all of the major phone and tablet form factors. And the application is also available in all of the major app stores. For those of you on our legacy field applications, we can provide an upgrade path so you can benefit from the flexibility, improved user experience, and ease of administration that comes with the newest products. Later this year, we'll be releasing a major upgrade to our desktop work management application. This new software gives you the tools to schedule, dispatch, monitor, and report on maintenance work in a modern web interface. We're excited to be a part of the Esri global community, excited to now be working arm in arm with Eagle in New Zealand, and most of all, excited to learn more about your goals and challenges and how we can support you. Thank you.
Thank you, Chris. Thank you for giving us an update on Clarion and where it's at. I'm also looking forward to seeing the uptake in New Zealand of such solutions. So finally, the final complementary solution that I'd like to talk to is Sight Vision. So Sight Vision is a Trimble solution, and it's an innovative way to view your assets in augmented reality. It provides a way to maximize your GIS data as well as a range of other data. As data professionals, we know that there is a range of data quality across New Zealand, and sometimes that data might not be completely accurate. So one of the things Sight Vision can do is integrate different types of data. That includes PDF as-built, so you can drape them on the ground in front of you and see where your features are. it has the ability to consume web services and even 3D meshes. There's additional functionality, including being able to capture photos in the field and taking notes, as well as measuring and positioning, having access to those measuring and positioning tools. So let's just take a quick example, look at a quick example using good old feature services. We all know the advantages of feature services. We can view these directly in desktop software such as ArcGIS Pro, like I have here, but we can also access them in online environments, such as local maps or an ArcGIS Online. Using that same Sight Vision, we can also take it into the next step and start to view our feature services out in the field through augmented reality. So using that same feature service, we can load it into Sight Vision, toggle it on and off, click on attributes, and get a better understanding of our existing data, as well as the environmental context, such as potential hazards and issues. This takes away the need for users to have paper plans or drawings in their pockets. So it's a pretty exciting space in the technology market. So I'm keen to see how GIS and augmented reality co-evolve and develop. With that, that brings us to the conclusion of the content portion of the session, with Q&A still to go. So I'd like to give a huge thank you to all our presenters today for sharing their stories and time with us. Just before we launch into the Q&A, I want to take this chance to highlight the remaining couple of NZEUC sessions that we still have. So next Tuesday, we'll have the Working with Imagery and LiDAR session. And 2 days after that will be the final NZEUC session, and that's the Making the Most of Field App session. So the link to register is on the page there for you. So with that, let's move into the Q&A session, and I'd like to welcome all the presenters back to the session. Hi, Matthew. How's it going?
Hello. I'd just like to say I have
David.
some engineer there as well in case there's any questions.
Cool. Awesome. And I think we're just waiting for Gert as well and Scott. Hi, Gert.
Hey, how are you?
Thanks. Hi, Aaron.
Hey team.
And Scott. Awesome. So thank you all of you for helping to present at today's session. I'd like to now take a look at some of the questions that have come through. So we have a question here, and this one is for David from PowerCo. The question is asking, how challenging has it been to integrate Copperleaf with ArcGIS?
Yeah, thanks. That's a good question. We have 2 streams for the integration with Copperleaf. We have finished the first phase of stream 1, and that was basically bringing data from our GIS system, our ERP system, and other data sources into Copperleaf. And that has been quite a big build. We have, on one hand, all the spatial derivations. That means we enrich all of our asset base with spatial information like distance to coast, corrosion rates, wind zones. For every pole, for example, we know does it have low voltage, subtrends, or distribution on it. So we process all of that. And then the data gets transferred into our Google BigQuery. And that's where we also bring together all the data out of the ERP system and other data sources. And in here, we also have developed all the business rules that can be set. And from there, we process all the data in Google Cloud and then upload it to Copperleaf. So that's the first phase, and the first proof of concept is finished and working. The second stream will be to get data back out of Copperleaf into ArcGIS, and we are about to start that project. And we'll see how tricky that will be. In theory, it's just an Oracle database that Copperleaf uses, but we'll have to see how we get that non-spatial information back into a spatial context. Yeah.
Okay, I see. So it's basically an Oracle database. Okay, cool. Thank you for that, David. Another question I have come through is a one for Gert. So this question, Gert, is saying, for existing tree data, what data formats can be imported into the tree management solution?
It's very basic and simple, right? They're just points, and it comes with a predefined schema. The feature layer comes with a predefined schema, so you just load your points into that schema and set all the attributes for the points.
Cool. So they're just points, as you said.
Yep.
Cool.
They're just points.
Just another one for you, Gert, regarding the LiDAR extracted features. How accurate are the features when they are extracted from the LiDAR data? And do you get any problems sometimes when features are inaccurate?
Yeah, well, accuracy depends on a number of things. For example, the point density of the LiDAR. So if you have lots of points per square meter, then it's easier to find the objects within the LiDAR. It really depends on the classification of the LiDAR. If you have good classification meaning that these points are vegetation, these points are power lines, these points are, support structures for power lines, for example. If the classification is good and if the point density is really good, then the extraction will be accurate. And if you then still have features that are inaccurate, that's why we're developing all these field applications. So you can go into field and move that point while you're in the field. So, hey, this point is still a meter wrong. It's been extracted wrong. I can move it in the field into the right position.
Cool. So you've got not only that input tool, but also kind of a QA, QC tool using those field apps to make the corrections. Cool.
Correct.
Thank you for that. I have a question here for Scott regarding asset management. Does Esri have any plans to develop an asset management?
Well, as you saw in my presentation, Megan, is that the solutions team is working on a number of pre-configured asset management solutions, but they're really tailored to individual industries. But as I tried to highlight in my talk, is that the patterns for managing your asset are generic. So, there is, like I said, a desktop configuration that allows you to enter all the assets into the feature layers. And then there is mobile apps to do the QA, QC in the field, or collect even new features in the field. And there'll be, dashboards to monitor your assets, and like I even said, a hub side for public engagement. So that pattern is quite generic. And currently we're working towards different types of assets. So we're also looking at a utility management solution following the same pattern. And we're even kind of, that's only researching, but how can we link with all these business databases, and how can we link ArcGIS in a nice way with all the information that lives in other systems, right? But that's still research that's ongoing.
Oh, okay, cool. Just got an update from the person who asked the question. She was meaning an asset management system. So yeah, I think the answer to that is that Esri will be still researching all of that. Like you said, Gert. Yeah. Cool, thank you. Just another one for you, Gert, regarding the tree solution. It's quite popular. Are there any plans to extend the tree solution to management of other vegetation asset classes, such as garden beds, groups of trees, shrubberies, and so on?
From Esri US, there is at the moment no plans, but what you really can do is, like I said, these solutions are open source and they're quite easy to, put your own feature layer with your own schema in. And we're really trying, like I said, this generic pattern that everything's driven by feature layers, and that feature layer has a bunch of fields, and whether that is garden beds, etc. You can modify these solutions and then leverage all the components. Yes. So it will work out of the box for trees and other assets that Esri US is not going after are possible, but you have to do your own configuration.
Cool. Thank you. I have a question here for Matthew. The question is, which web apps was TPR Envision built upon, and why did you choose those web apps in particular?
Okay, it was built, it's a combination of a story map, you know, the tabbed, it's a series story map with an embedded web app builder application as the main tool. But I know that in the demo, I didn't demo the first two tabs, so it has an information, which is kind of the Cascade story map got thing. And yeah, two tabs, but the actual tool itself, where you can explore the data, is on a web builder.
Cool. Thank you for explaining that. I might go back now to David. A question here regarding if it was possible to share the poll risk model that you and your team developed.
Yeah, absolutely. Yeah. Just get in touch with me. My email's on the screen. We're always happy to share these things. Absolutely.
Cool. Yep. As you said, David's email's on the screen, and after the conclusion of this presentation, all of the information will be, all of the presentation will be uploaded to YouTube, so you can find out details from there as well. Thank you. Just a question on the utility network that maybe Aaron can answer.
Yep, sure thing.
So the question is asking, what are some of the important considerations when migrating to the utility network? We've heard good data is a must.
Okay, yeah, maybe I could rephrase the question a little bit as what are some important considerations when preparing to migrate to the utility network? Can't understate data quality enough because the utility network framework is heavily rules-based and it has to adhere to a topology. The accuracy and currency of your data is probably the most important thing. Can't really understate that enough. Preparation's everything. So if there are any if you take the approach of mitigate before migrate, will put you in a good place. So having a look at the quality of your data is probably the most important thing during the early phases, even before you're thinking about migration.
Cool, thank you. Yeah, really strong emphasis on data quality and preparing that before you even think about the migration process. Thank you. Just looking at my list of questions. There's another one for Matthew. This question is regarding your, lost myself, regarding the circuit load values that you were showing. So the question is asking, is there a possibility of adding a feature which allows you to visualize the whole country's circuit load values, which then can be filtered by year so we can see which areas could be better for new developments at a given time?
Yeah, so hi there, Sujata here. We did consider doing that where you can kind of like scale through time and see things change, but we decided to go against it when with our user testing. We realized it was more important to just show what we had in the report, and it doesn't, in the report, it's only a subset of issues, especially like the circuit overloads. It doesn't comprehensively show like all the issues. It shows like a subset. And so if we were to do like a scale through time and show like different issues showing up, I think it would be a bit misleading. So yeah, that's kind of the reasoning behind why we didn't do it in that way.
Okay, cool. Thank you for your explanation of that. That was very helpful. I see that the time now, we're just a bit over. We have a couple more questions, but in the interest of time, we might just wrap it up here, and we will collate all the questions we received and send them back out after the conclusion of all the NZEUC streams. So we'll call that a wrap here. Thank you again to all the presenters and panelists who joined us today. Really appreciated your time, and thank you for watching. I hope that you found this session helpful. And again, stay tuned. We'll be uploading the recording to this soon after the presentation. So thank you very much. and have a good rest of the day.
Thank you.
So,
Thanks.
thanks, team.
Thank you.
Thank you.
There you go.
Thanks, team.
Bye-bye.
Good job.